Okay, so many of you are here to expand your knowledge of Python to perform more efficient and complex GIS problems, GIS analysis. Many of you want to use Python for different tasks related to geology, and some of you want to just generally improve your knowledge of Python and programming. Some of you already have some experience with Python and you want to just refresh your memory. For some of you, the connection between Python and geography is important and it's very relevant. You will learn more about it a bit this course and continue in the second course. Yeah, visualization. And yeah, so you're in the right place. We will also take into account your responses here to fine-tune our course materials for this year. But let's get started with the the main part of today's lesson. So what we want to do in this remaining time today, first of all, I want to show you the tools that we will be using for the course. As I said, there are many pieces, so we will have a look at them to see how it works and what we need during these weeks of this course. And for those of you who are continuing to the second part, we will use a similar environment. So once you get used to it, it's easier to continue with them. We will explain the basic concepts. Well, we went through the second one already. We will define, then we will look at Python. We start with variables. We will see how we can define and use variables in Python. Very basic but important thing in programming. Then we will describe the concept of data types in programming, and specifically Python in our case. And we will learn how to determine the data type of a variable in Python. So this is the practical part of our lesson today. So in every lesson we have this page, lesson overview. It's the same place where we publish the lesson videos. So there is one video from previous years where we talk about good coding practices, specifically related to naming variables. We will go through that today, but this is also a good, very detailed video, so you can check it out. So tomorrow or day after, when we will publish the lesson videos on this page for every week. Yeah, so one quick reminder, David already sent you an email, I guess, on Friday, and he asked you to participate in a poll. If you haven't already participated, please do so. But there are a lot of important questions we have asked, but particularly one thing is related to the programming pairs, because you will do the exercises in pairs in this course. We will form the pairs ourselves, but if you have any specific wishes, this is your chance to express it. Otherwise, we will just go ahead and form the groups ourselves. Yeah, so please check that email if you haven't seen it already. So let's look at the course environment, and this is very practical. So the interactive part of this course will happen in JupyterLab environment. Has anyone here used JupyterLab before? Yeah, a few of you have used, but not many. But we will use it during this course, and you will get used to it. So JupyterLab is a very user-friendly, interactive environment where you can write your Python code. We will see shortly how that works. So JupyterLab needs to be hosted somewhere. So for those of you who want to just use your own local environment, there are instructions here how to install Python. So installing Python at the bottom of this page. So if you want to install Python locally on your computer, there are instructions how to do that. There are a number of libraries that we are using for this course. There's a list of them. You can just install Python and run it locally. But you don't have to do that because we are using CSC services to host a readily made version of Python for this course. So we have installed, it's using Python 3.11 something, and we have installed all the libraries that you need for this course. So it's a hosted JupyterLab environment. So we are using CSC. Something you might have noticed up here, this course's webpage, as I say, is an open course, so it is hosted on GitHub. And GitHub is something that we will get back to next week. we will use it for this course. So you can find the repository of this course. There are details about, for example, the libraries that we are using, the requirement TXT file. You can download the lessons as a PDF or RST file, and there are a number of things you can do. Well, this is a static page, but the pages where we have code running, you will also see a binder option up here. I can show it to you later. So binder is also another way of like interactively running the code on this page. So I will show that later, but maybe here we have it. Yeah, so this is the sign for binder. So this is a special for Finnish students. You have those who are studying here or exchange students here. You have access to CSC services, so you don't need to use binder. This is especially for relevant if you are using this from outside university. You can just click on binder, and this will just open a session where you can run the code live. So yeah, but it's slower, and we don't use it so much in this course. Yeah, but we will get back to CSC. We will shortly look at it. Then Git and GitHub. This is one of the things you have to do this week as part of your exercise, and that is to create a GitHub account if you don't have it already. If you have one already, you don't need to create a new one. You can just continue using that. So GitHub is a place, we will talk about this next week, but it's a place where people, programmers, share their code. So this is also the environment we are going to use for your exercises and also delivering the materials for the course. Voting and polling, you already saw that during this course we use a lot of polls. Every lecture we have a few of them, and for that we are using Presemo and Discord. Again, you already got the instructions in the email, and this is one of the things you have to do as part of your exercise for this week, and that is to join the Discord server of this course. And that will be our primary way of communicating. Of course, you can reach us via email, but that is more effective, and also instructors are there so they can respond to your questions more quickly. We try to be as available as possible during work hours to answer your questions. So yeah, so if you haven't joined Discord already, please do so. And it's needed for the first exercise. Yeah, so you can, about JupyterLab, this is how the environment looks like, and we will open it soon and you will see. But it's a very nice interactive way of using Python, and at the same time you can have documentation like markdown files, markdown text, which makes it very handy and useful. So that's JupyterLab, and if you want to learn more about what JupyterLab is and who are the people behind it, then you can just follow this link and read more. CSC, we will get back to this. I already showed you the binder, and binder is a bit slow, especially at the beginning, but CSC is better. So in this course, the JupyterLab environment we are using is hosted on CSC Noppe. So it used to be Notebook until a few months ago. Now they have changed the name to Noppe. So in this course and in other places, you might still see references to CSC Notebook. So it's the same as Noppe, it's just a new name. It takes a while to get used to it. But yeah, so the address has also changed to noppe.csc.fi. It used to be notebooks.csc.fi. I guess if you go to notebooks, it still redirects you to this page. But yeah, that is the address. So let's do this now together. Let's open CSC Noppe, and we join the environment for the course. They are not yet fully done with their development, so the domain name is still weird, but it redirects you to the right page. So once you log in, you can log in with a CSC account. You can just create an account, or more simply, you can use just this Haka login that you are used to if you're coming from a Finnish university. So you can just log in with your university credentials. So I have a CSC account, so I just log in using my account. For you, it looks different. I have used this before, so I have other stuff you don't have yet. But on the course's web page, there is a code here, number 5. You will use this node to join the specific environment we have created for this course. So what you do, you just copy this part of text. This piece of text is starting with Geo. And in Notepad, there is a button called Join Workspace. If you click that, you can just paste that code and join the environment. I'm not going to do it now because I have the environment already. But once you click, there's this place. Just this text box, you paste the code, and you should, then the course's environment should be added. It's called Geo-Python-2024. So if you use the CSC environment, you do not need to install Python. You don't need to install any library. Everything is just ready. And every lesson, every week when we come here, we pull the changes from GitHub, so we get the new course materials for the week. Also, this is where you can do your exercises. So it's like a place where you can write your code and run it, and then you will see how you can submit your exercises later. So did all of you succeed in doing this? Yeah, great. So once you have this added, then there's this power button here. So if you just click on it, it will open an instance of Python environment for you using JupyterLab. So it will take a few seconds depending on resources available on CSC. Sometimes it's shorter, sometimes it's a bit longer, but it shouldn't take more than a minute or so. So this is the JupyterLab environment. So one important thing here. When you open your JupyterLab environment, you have two folders here, shared and my work. Shared is like for us, if you want to share a file with you, I will just drop it into shared folder and you can all access it. So you shouldn't put anything there. I don't think you can even put anything there. Then if you save anything here outside those folders, it will disappear every time you open a new instance. So now we open the new instance, CSC instance, and it's running for 4 hours. So if you open this in the evening or tomorrow, everything you have saved outside my work folder will disappear. So if you don't want to lose your work, just use my work folder. So whatever you save here, whatever folder you create or anything, it will stay here whenever you open. So remember to just save your thing in my work folder. Otherwise, it will just disappear next time you open it. So this is JupyterLab environment. It's like it has a nice interface, so it's quite easy to use. There are a number of things you can work with. We will learn more how to work with this during this week. But a number of handy things. So if you want to create a new notebook file, notebook is what we will use a lot during this course. It's a combination of code and markdown text, and you will see it shortly. But yeah, you can create a notebook file. For example, for your exercise this week, you need to create a notebook file. So what you do, you go to the folder you want to work in. So here you can create a new folder. You can name it like exercise 1 or whatever. Then you go in the folder, then you can create a new notebook and do your work. But we will see that soon. You can open a Python console for those of you who are a bit more experienced with Python. You can open a Python console, but you don't need it really. This is a Linux-based machine on CSC, so if you need the terminal for running whatever command, for example, if you want to use Git over command line, then you can open a terminal here. You can do other things, create a markdown file, Python file, and a number of things. But yeah, so what we are going to do now is this is something that we will repeat pretty much every week, and that is to get the latest changes of course, getting the materials for every week. So I'm going to you don't have this is just something I've created, you don't need it. Let's create a new folder. Actually, this is for folder. I'm going to call it lessons, and this is where I will download or clone the lesson materials every week. You can name it whatever you want. Lessons work for me. Then I go inside the directory. So then next thing I'm doing, I'm going to, as I said, the material for this course is hosted on GitHub. So there's a repository for that. So So what I'm going to do, I'm going to clone or just download the data from GitHub to my course environment, to my CSC environment. We will learn more about GitHub next week, but for now, let's just get our materials. So there is a plugin here. It's a GitHub plugin. And there's a button, clone a repository. So it will just help you download the material from internet, from a repository. So what is the address for repository? You can find that from the course's webpage. Yeah, so if you scroll down a bit, there is this note, number 4. This is the address for, so the lesson materials are uploaded here weekly. Just copy that link and paste it here. You don't need to change these options, just clone. So now you can see in my lessons folder, it was empty before. Now I have a folder called notebooks. And there is already L1, lesson 1 materials. And there are 2 notebook files. Let's just open the first notebook file to see what it looks like. So this is the environment you will use for this course, for doing your exercises, for doing the lesson materials. So this is what a notebook, Jupyter notebook looks like. There is text combined with cells where you can write a code and execute the code. So it's very handy. You can have text, you can have your documentation. In our case, we have the instructions. And then you just write a code in Python and write it. So this is how we do things. You write a piece of Python code in the cell, and in order to run it, you have to press Shift Enter. So once you do it, it runs, gives you the output. And this is something we will be doing all the time during this course. So that was one of the main things we are doing this in this course. This is one of the main environments, so you will get used to it over time. And yeah, so we will get through this, go through this next week, but every time we add a new lesson, so every week, you will see that this, you will see, there will be a marking here showing that there is new stuff added. I guess there will be some orange sign. So you will pull the changes every week, but let's go through this next week. And as I said, you can use CSC or your own computer. It doesn't make any difference. But in your own computer, you have to install the environment. And that's it. So I guess we can start with writing some Python code already. So did you all manage to come this far? Okay, great. Yeah. Yeah, you just go to, then it just appears. Wherever you have cloned it, it should be downloaded. So I just cloned it inside this folder called lessons. Then this folder appeared, this notebooks folder. Do you have it there? I use this plugin. Okay. Okay, so let's start with very basic thing. So let's just do some simple math operation. So I'm just going to write 1 plus 1. That's the simplest piece of code you can write. And if you want to execute it, just as I said, Shift Enter. And it gives me the output. So I just simply wrote something in Python and I got the output. You can try out different things, play with it a bit to get a sense of how it works. You can use different math operations. So I'm going to use 5 multiplied by 7, like the example in the text. Get the output, 35. So take a minute to just try this out. So, yeah, so one useful concept in almost every programming language is functions. So functions are a ready-made piece of code that you might have written, or you might have just imported a library, and that library comes with a bunch of things, including functions, that do certain calculations, perform certain tasks for you. So every time you want to do that, you don't have to write your own code, you just use that function. So in mathematics, there are a number of things like that. For example, if you want to get the square root of a number, well, there is a mathematical thing behind it. But do you want to calculate it every time, or just call that function to do that for you? So I'm going to start with something mathematical and simple. So I want to get the sinus of 3. And I run the code. And you get an error, because, well, this is an error that you will, well, this is how errors look like in Python. So it's just giving you a traceback, telling you that, okay, there's a name error. So Python is not recognizing the word sinus. So this didn't work. So let's try to get the square root of some number. So I want to get the square root of 4 to see if Python can do that for me. Again, I get the error I get a name error telling me that, okay, Python has no idea what sqrt means. Does anyone know why this is happening now? Exactly. So, yeah, so there are a number of basic things like this basic map operations, like addition, subtraction, multiplying, and so on. But these are just ready. For doing 1 plus 1, you did not need to import anything. Python readily knows how to handle those. But for anything more complex, and this is how you do the math operations in Python. So plus, minus, for multiplying, for division, and if you want to use power or exponential, then you use just this double asterisk. So that's how you do basic math operations. You can try it now. You don't need to import anything. But if you want to use any other function that is not readily coming in the environment, then, well, there are some modules or libraries. Both terms are used. Module or library is a piece of code that someone else has developed, and you want to repeat their work, so you don't write your own code. So someone has already figured out how to calculate sinus or square root of numbers. So you don't have to do that anymore. So for those, you have to import the library that you need. So this is a Python's way of keeping things light. So if you're not using sqrt, you don't need to import a library. It just stays light and simple. Some libraries are built in. So if you install Python, for example, for doing the sinus and sqrt, we need a library called math. And that's built in Python library. So when you install Python, it's there. You just have to import it if you want to use it. But sometimes, like later during this course, we are going to use a library called pandas for data processing. And that one is not built in. You have to install the library, then you import it. But in our case, this math library is already installed. So in Python, if you want to access the library, if you want to use it, you just use import and then the name of the library. Then you run it. Now this math library is available to you because you imported it. So Python knows that you are going to use this. So that sinus function that didn't work before, it's coming as part of this math library. So if you want to access it, you have to tell Python that inside math library, which you just imported, there is a function called sinus. And I want to use that function to calculate the sinus of 3. So now if you run this line of code, it works. So now Python knows that, okay, I'm using sinus function from math library. So now let's try it for the square root. So similarly, I know that in math library there is a function called the square root, or sqrt for short, that can calculate the square root of any number for me. So I'm just using sqrt of 4, which gives me 2 as the output. So this is how you use functions. We will get back to the topic of functions. We have like a lot of details we will cover, but this is a quick view of how functions work and how you can access functions from a library in Python. So libraries can include many things. Very often they include many functions that you can access and use for doing calculations. Very often they include classes that we don't use much during this course, but they also can include constants. So in case of the math library, if you want to get the output of, if you want to know what is the pi value, pi number, so from math, you can just get the output. So math.pi. So this just gives you the pi number, a certain number of digits. So it's a built-in, it's already defined as a constant in the library. So if you want to use pi, you don't need to type in 3.1415, whatever. You just import it from the library. Okay, so now based on what we learned, let's take 1 minute or two to calculate the sinus of pi value. So there's an empty cell here for you, so just write what you need to write. So one quick thing, in Python, if you want to write comment, you can put this hashtag sign, this sharp sign. So when you put that at the beginning of line, that line is not executed. So it's just a comment. You can just write things for yourself. And that's a good programming practice. Because when you write a big program, you may forget, okay, why did I do this? Well, what does this variable mean? But if you put yourself a comment, then you will remember. So if I run this cell, nothing happens because I just have comments and comments are not executed. But if you don't put this hashtag sign, if I run this, you get an error because it's trying to execute that text and that doesn't mean anything. So that's the way of creating comments. In different programming languages, there is different syntax for writing comments. This is one way of doing it in Python. There are other ways we will see later. Yeah, so did anyone manage to get the sinus of pi? Yeah, a few. Okay. So let's now do it together. So I already know that I can access the function using math.sign. So this is my function. And for the pi value, of course, one lazy option is to just use the value, but we learned that we can get the value without typing anything with all the not all the decimals, but with many decimals using how it is defined already in the library. So I'm just writing math.pi. So what it does, it gets this one first, it gets the pi value for you, then it's used as an input for the sinus, and then you run it, you get the output. So the sinus of pi value is 1.22 and more. So sometimes you need to combine functions. So a function within a function. So the output of one function is used as the input of the other function. And doing that is easy. So one built-in function of Python that you will use a lot is called print. So this is the syntax. You just write print, then you have this brackets, and inside that whatever you write will be just given as output. So if I just, for writing text you need to put it in quotation. So I want to just write hi, whatever text you want to write. So if you just run it, it gives it as the output for you. So there you can put anything. You can put numbers, you can put operations, or you can also put a function. So in this case, I want to print the output of math, the sinus of, or let's go with the SQRT this time. SQRT of 4. It gives me the output. So one thing is that here you might think it's unnecessary. Why did I even print it? And the reason is that in JupyterLab, when you run a cell, it shows you the output. But if you use it in other Python programming environment, unless you print it explicitly, it won't show you the output automatically. So that's why this print function is very useful to show you the output. But in JupyterLab, it happens automatically. But anyway, this is an example of how you can use nested functions. So a function within a function. So this math.sqrt is a function. It gives me the output 2 as the result. Then this 2 is used as input of print. Then print just prints it for me. You can also combine text with other calculated values using the print function. For example, okay, let's try this together. So I just write print. Then I want to first add a text. So you can use this double quote or single quote, doesn't matter, whatever is your habit. Some people use this single quote. So then I want to write a piece of text. I want to write 2 plus 2 is, 2 plus 2 is. So Python just reads this as a piece of text. It doesn't think about the content. So you can use whatever within this quotation mark. And then I put a comma. I want to add another input to my print function. And that is 2 plus 2. And remember to close the bracket. If you don't, you will get a syntax error. So I will run it now without this bracket at the end, so to show you how it. Look, this is an example of an error. So you got a syntax error. So there is a problem with your language. Python expects you to close the bracket and you didn't do it. So it was vague. It didn't run it. So you got an error. So I close the bracket and run it again. And you just get the text plus the value. So you can combine text and number when you are printing something. So take 30 seconds, 1 minute to play with this. You can alter the text, see how this works. So now you calculated something. You calculated the square root of 4, and you got the output. Great. But what if you calculate something now, and you want to use it later on in your code? So your codes are not always like one line of something. It can get long. It can be like, I don't know, hundreds of lines of code. So once you have calculated the square root of 4, and you need it, and this is a very simple example. Imagine you have done some mathematics, and you have calculated something. You want to have that calculation stored somewhere. So if you want to use that number, the value, you can just call that. So for that, all the programming languages have a concept called variable. So a variable can be used to store values calculated in an expression. So these values can be numbers. We will get back to data types, but it can be a number, it can be a piece of text, it can be Boolean. We will get back to that. But it just stores the value for you. So how do we assign variable values? So first you have to pick a name for your variable. And we will talk about how you can pick this name wisely. But it doesn't, to Python, it doesn't matter what you pick. So as long as you follow certain rules. So I'm going to call it temperature in Celsius. So temp underscore Celsius. Then I'm going to assign a value for it. So I use this equal sign. And I'm just assigning a value for it. So 10. So I'm putting the decimal here. Mathematically it doesn't make difference, but I'm putting decimal here to tell Python that this is a float. So I have decimals in these numbers. So in some programming languages, like some of you have used C-based languages, you have to explicitly say that this is integer or it's a float. In Python, it's just it's like this. So now it knows it's float. You don't have to explicitly say this is a float. So now this value is stored in the under the name of the variable temp Celsius. So if I want to print this, I can just call the name of the variable and it can access the value for me that is stored in it. So print temp Celsius. It just gives me the value. So this is a very simple example, but it shows you how you can access a value that you have stored or calculated before. Now I want to make this a bit more complex. So I'm going to use the print function again. And I want to combine a bunch of things. So first I want to add a piece of text saying temperature in Fahrenheit. And then I'm going to do a calculation. So this is the formula for converting temperature from Celsius to Fahrenheit. So this is how you calculate this. 9 divided by 5 times temperature in Celsius. So I've already stored the value in this variable. So I'm not typing 10 anymore because I have the value. Temp underscore Celsius plus 32. So the mathematic part is just how Celsius is converted to Fahrenheit. So if you just run this, if you don't have any typos, any mistake in the line of code, you should get this output. So it tells you that temperature in Fahrenheit is 50. It's also possible to combine two pieces of text. So now take a minute or two and try something. Write two pieces of text and store each of them in one variable. It can be any text you want. You can, for example, say variable 1, I like, variable 2, Python, then print them together, just using the name of the variables. See if you can do that. The text can be anything, just store them in separate variables. Okay, so I also start writing slowly. So I want to write a comment first, just as a good habit. This is a useless comment, but just reminding you how you can use it. So here's my solution. So this is a piece of text for myself. Then I'm going to store one variable. I'm going to name it part1. And as I said, in a variable you can store anything. It can be number. It can be text. So in this case, I want to store a text, and I want to write I like. Then I'm going to create a second variable, which is also a string or text. And I'm going to say I like Python. So now if you run this, nothing happens. Just the variables are defined. They are available. You can access them later. But I'm going to add one more thing here. I'm going to print the output. So part1 and part2. So let's run this and see what happens. So it just puts the two variables next to each other. So the output becomes just I like Python. So you can just access different variables in one function, and in print function it works like this. You can put the strings together. Yeah, so in the second part of now our practical lesson, we will see how we can name variables. So we will get into more details of that. But as just briefly saying that the name of the variable is important, not for the program, for the Python itself, but for you. So imagine if you have a big program and you choose names that make sense to you when you write them, but imagine you're checking your code after a month and you have just named something S4, or I don't know, some abbreviation you may not remember anymore. So you should avoid those kinds of names because it becomes a headache. Like if you want to check your code after a few months and you have no idea, you have to like read the whole code to remember. So pick names that are reasonable. So one thing is there are a number of rules. We will go through this, but you cannot have space in the name. So if you want to write temperature Celsius, I couldn't write temp space. That's why I put the underscore. But sometimes you want to have multiple words. So for me, temp alone is not enough because I wouldn't remember if it is in Fahrenheit or Celsius. That's why I wanted to have Celsius. So that's why I picked the name like this. So temperature underscore Celsius. So this is called a pothole case naming. So you separate multiple words using underscores. So use underscores because if you put a dash, Python thinks this is like subtracting. So you don't want to confuse Python. So you just use underscore. So this is one way of naming things if you have multiple words. Another way is using capitals. So if you just write temperature Celsius without anything, it's a bit hard to read, especially if you have multiple words. To make it a bit more readable for yourself, you can put this C capital. Again, this doesn't make any difference for Python. It's just for your own convenience. So now you can play a bit with this. Just think about different names for different variables and how you can write them. But we will get back to this shortly. See, if I put a dash, it just gives you an error because it gets confused. It doesn't know if you're doing mathematics or what. But underscore works. There are also a number of words that are reserved. Like, for example, they're part of the syntax. For example, the word for in Python is for writing for loops. Or the word print, you saw it's a function, you use it for print. So if you name your variable print, Python doesn't like it because it gets confused with it's a reserved word. So you want to avoid those reserved words. So updating variables. So once you assign a value to the variable, you can always change it. And it's sometimes very useful. So you calculate something, then you calculate again, you update the value. So it's not a problem. So now we stored the value temperature Celsius 10 earlier. So up here we had stored. Yeah, so now the value for temperature Celsius is 10. So if you don't believe me, I will run it again to see what value is stored. It's giving me 10. So it's still there in the memory of the computer. But if I want to update it at any time, so now I want to say, okay, I changed my mind, temperature is 15. It's not 10 anymore. So if you just update this, it changes the value. So at any time you can change the value of a variable. So here I just put the name here, JupyterLab will print the name for you. If you are not using JupyterLab, you can just put it inside a print function. So I just updated the value of the variable simply. So remember, if you are using a variable name that has not been defined yet, so now this temp underscore Celsius is defined. We are running it, I have a value in it. But do we have a variable called temperature Fahrenheit? No, we haven't used that. So if I run this, it's going to give me a name error. Because I've never used that variable, it's an unknown name, unknown word for Python. So it's just giving a name error. So if you want to use a variable, first you have to define it, you have to have a value in it. Then it's accessible in your code. So when you're working in Python, in JupyterLab environment, remember that if you, well, sometimes you're doing your exercises, well, this is how you will probably work. You start working on your exercise, you do a piece of your work today, then tomorrow you want to continue. And if you have a value up here, unless you run this cell, the code is not executed. So next time you open this notebook and you continue working from here, because that's where you stopped working last time, if I write temperature Celsius suddenly, it gives an error. So if you start working again, starting a new session, you have to run every cell. So go up here, I run this cell again. Now this temp Celsius is again accessible. In JupyterLab, there are also this button. So it will run all the cells from top. So if you have a long program, for example, your final assignment, and you want to run all the cells, not one by one manually, you can just click on this button. It just runs all the code again. So it also restarts the kernel. It's like the Python engine. So sometimes if you have like bugs, some problems, it's useful. If it crashes, then you just rerun the whole code or just restart your kernel of the Python engine. So that's sometimes helpful if you're stuck with something or if something's not working well. They are submitted, yeah. They are submitted. Yeah, for this course, we will talk about this more next week, but we are using GitHub Classroom. This is a service related to GitHub, so your codes are essentially on GitHub. You just give us access to your repositories. But yeah, they are submitted. And remember that the name of the variables are, of course, case sensitive. So if you define a variable with temperature Celsius T capital, it's different than T, the lowercase. So it's case sensitive. So if you get confused with that, you get errors, of course. So now I'm going to calculate something. So I'm going to calculate temperature Fahrenheit and store it in a variable. I skipped a few cells because I did everything up here, so I just continue from here. I'm going to create a new variable called temperature Fahrenheit or temp. And to make it more readable, I just use the uppercase here. And here I'm going to do my math. We already saw that this is the way to calculate, convert Celsius to temperature Fahrenheit. So it's 9 divided by 5 multiplied by your temperature in Celsius, which you have already defined. The last time we defined it, we assigned a value of 15 to it, so it's 15. And then it's plus 32. So if you just run this, it gives you nothing, but it has calculated the value, so it's stored in temperature Fahrenheit. If you don't believe me, you can just print the output and see what it looks like. So I'm going to print it. If you run out of cells and you want to write a piece of code here, in JupyterLab you can just create a new cell here. It adds it under or above where you're working now. So if I click here, it gives me a new cell. So if you're working and you run out of cells, you want to write something else, you can write it here. Up here, when you select a cell, you can choose what is the content of that cell. So you can choose either it's a code, it will be treated as a Python code, so it will be run using Python. Or if you add it as a markdown, you can just write whatever. So this text you see here, these are basically markdown text, so they're not code. They're markdown. But this is a code. So if I mark this as a markdown and I run it, it will be just treated as text, not code. So be careful when you are using cells, make sure it's code if you have code there. But if you want to write text, for example, explanation of what you have done, just set it as markdown. So this is the code, I just run it. And then I want to print something. I write print, so temperature in Celsius. I'm a lazy typer, but you can write the full word. Temperature Celsius. So first I print what is the temperature in Celsius. Then here I add the value, which I have stored already in the variable called temp Celsius. Then I add another piece of text. Remember to put the quotation marks and in Fahrenheit it is I'm going to just copy the name of this variable so I don't have to type it again. If you just run this, you can see that, well, you have the text you just typed in, and it accesses the values of the variables, and you get the output. So this is kind of obvious, but just as a reminder, if you have multiple variables and you change the value of one variable, the other ones are not affected. So now we calculated Fahrenheit based on Celsius. If we update the value for Celsius, unless we do the calculation again, the value for the Fahrenheit is not automatically updated. So let's just see this in practice. Now I'm going to update the value of my temperature Celsius to 20, so it was 15 last time I ran it. Now I'm going to print something a bit longer, and to make it a bit more readable. Of course, you can write one long print with a lot of text, but to make it a bit more readable, I'm breaking it into lines, so Python understands that it's still within the same statement. So print, I'm going to write temperature in Celsius is now. Then I put the name of the variable. The temperature in Celsius is temp Celsius. It should be now 20 because that's the value I assigned. And temperature in Fahrenheit is still So now you can see that you updated the value for temperature Celsius, but the output you're getting for Fahrenheit is still 59. It didn't change because, of course, we didn't rerun the calculation. The value in the other variables is still the original value. So one thing you have already seen is different data types. So in Python, when you're defining variables, when you're assigning a value to variables, there are different data types. So as I said before, in some programming languages like C, C++, you explicitly mention, you explicitly declare what is the type of the variable. So you say float temp Celsius equals something. In Python, it just guesses what is it. Based on the input you provide, it knows what is the type. So it's a bit less writing for us. So there are different kinds of there are 4 main data types that we use in Python, and they're quite similar in other programming languages. So we have integers, and the name for it is int for sure. So it's just a whole integer value without decimals. Then we have floats. So So you have decimals, for example, the pi value. Then we have a string, it's a text. So you put it in quotation mark, it becomes a text. It's a string. And then we also have Boolean. So it's logical. It's 0 or 1, true or false. So sometimes you have a function that is just checking validity of something. Like, I give you again a GIS example. You write a function that checks whether a point is inside the boundary of Helsinki. You have written a function. So what output do you want? You just want to know yes or no when you provide the point. So what you return is, it can be Boolean. So if it is true, it's inside the polygon, inside the Helsinki boundary. If it's false, so Boolean is like this. True or false, 0 or 1, both of them work. So there is a function that comes in the package with Python that can check what kind of data type you have. So now I'm going to define a new variable. I'm going to call it weather forecast. And inside it, I'm going to say, okay, the weather is hot, as simple as that. If I want to check now what is the data type in my variable, I can just write type. Type is a built-in function, so it's also one of those reserved words in Python. And then inside the bracket, I provide the name of the variable I'm going to check. So if I just run this cell, it gives me a str, or string. So it's a character string because it was in a quotation mark. So Python knows that this is a piece of text. Okay, now let's check this for our other variables. I want to check the temperature, the variable temperature Fahrenheit that we defined earlier. So temperature Fahrenheit is float because we have decimals. So Python knows it's a float. So what if you, well, depending on the type of variable, there are certain operations you can or you cannot do. So here we have, let's try something. So temperature Fahrenheit. So I just wrote a simple equation. So one thing is that temperature Fahrenheit, I'm recalculating temperature Fahrenheit, like I'm adding 5 degrees to it and multiply it by weather forecast. And then I again store it in the same variable. But once I run this, I get an error. And the error is type error. Do you know why I get this error? Exactly. It's a string. So I'm multiplying 5 by weather forecast. And the value for weather forecast was hot. It's a string. But what does it even mean? Again, it's vague for Python. Like, what does it mean 5 times hot? So you get a type error. So this is a very simple example, but sometimes you get this if you have mishandled your data types. It tells you that there is some problem with your calculations. Okay, now take a minute or two and try this part. So define 2 variables and assign them character string. You can write whatever text you want. And let's see what happens if you try to add 2 character strings together. So instead of 5 plus hot, what if you write temperature as text plus hot as text? Try different operations like multiply, subtract, plus. See what you can do with strings. Okay, so now let's try and do this together. So now I'm going to define a variable and call it var1, variable 1. And I'm going to store a string in it, so I'm going to say, I will say Python there. Then another variable which I name var2. And you can write whatever text you want. I write is cool. So print. So if I add var1 to var2, so if you just add two strings, it just attaches them together. As simple as that. So Python is cool. So I could have put a space here to make it look nicer. So what if you multiply var2? So 5 times var2. So it just repeats that string for you 5 times. Yeah, so subtraction doesn't work. So we could use multiplying, we could use addition, but with subtraction we got error. So it's just telling you that unsupported operand. So this doesn't work for str, which is a string. Yeah, so the contents we covered so far are from the book, section 2.1, Basic Elements of Python. The lesson continues with lists and indices, but we don't go through that yet today. So we will continue. So we didn't study the whole thing here, but up to here. But one last thing to do before we wrap it up for today is this. Let's open this second notebook. So by default, I guess this is on, auto-save documents, so it automatically saves your document here. But of course you can save it yourself. You can press Control S, or you can just use this sign. It will save the notebook for you. Don't push anything to GitHub or anything. This is just your own copy. Let's open this new, this other notebook file. Yeah, so I briefly talked about this, but now a bit of more detail. So every week we have a section called GCP, or Good Coding Practices. As I said at the beginning, one of the things we want to achieve during this course is to get used to using good coding practices. Because as part of motivation of the course, I said that one of the reasons we use programming can be to share our work with others. So if you have done some calculation in some software and you want to give it to someone else, it's a bit difficult. How do you give them the files? What if they don't have the software? But with Python, you can write a code. It calculates something. It converts Celsius to Fahrenheit. If you want to give it to your friend, you just send them the script. They can run it as long as they have Python in their environment. So you want to make your code reusable. There are a number of ways. By following good coding practices, you make your code a bit more usable. So today, the good coding practice we are going to go through is selecting good variable names, which I already mentioned briefly during our practical. So examples of some not so good variable names. So if you just get a piece of code from someone, and there is a variable called s, and it equals some kind of some number, here it's a string actually, it doesn't tell you anything. So what is s? Even if you have written this code, after a month or two, you may not remember. Similarly, when you're writing the code, if you write SID, you might think it means something, but I can guess ID is some kind of ID, but what is S? So it's a bit tricky. Then you might want to be a bit more explicit with the name and go a bit too far and put something like this. So this works with Python. Python is fine with this, but are you fine with this? Imagine if you want to redo, you have to type this in every time or copy it. It's just a lot of work and no one can read that. So do not overdo this. So add a bit more detail, avoid very short, like one letter name, because it's hard to remember what it is, but then don't overdo it. Don't make it super long. Be as brief as possible, but try to make sense, to make it obvious enough for whoever reads your code. So yeah, so this is also a bad example of picking a name for your variable. So what is a good name? You should try to be clear and concise, so it's understandable what it means, but it's not overly long. It should be written in English. Python handles other languages quite well, so if you're using Finnish and you use those special letters that are not in English, it probably works fine, but it's not a good practice because you might share your code with someone else and then they might have problem if you have those letters. So avoid that. Try to use English because that's the dominant language in world of programming, but of course it depends on your use. If you really must use Finnish, for example, you can, of course, no one stops you, you can use Finnish. But if you are thinking of sharing your code scientifically with the world, then it makes sense to choose a name that is English, for example. And yeah, as I said, other letters are supported, but you know, sometimes you might run into problem if you put those special characters. And like I mentioned before, there are a number of words that are reserved Python words. So there's a link here, you can see a list of words that are reserved in Python. So these are words that do something in Python. They mean something to Python. So if you just use them as a name for your variable, Python gets confused. So it doesn't accept them. So values such as true, false, and, if, for. These are Python values. These are keywords in Python. So you cannot use them as your name of variable. So how do you choose a good name? There are a number of possibilities. There are a number of good practices. Again, this is a good habit. It's not a must, but it's a good habit. So one of them is this pothole case naming, which we already saw. So if you have a number of values, then you just separate them using an underscore. Then it's a bit easier to read. So FMI underscore station underscore ID. So this makes a bit sense and it's not overly long. Another recommendation is called this camel case naming, which we saw. So if you have multiple words, you use a combination of uppercase and lowercase to make it a bit easier to read. So as I said, you cannot use a space here. So if I put this S in uppercase, it makes it a bit easier to read multiple words. Yeah, so that was good coding practice. There are links here, you can read more. And as I said, there is on the course's website, there is a video from previous years with more details. It was here, that's an overview. So if you want to learn more about naming variables, you can watch this video. Just quickly about exercise 1. So exercise 1 is a bit different. In next exercise, it's mostly about programming, coding, but in this exercise, we have a number of things we should do. So the deadline for your exercise is next Monday before this lecture starts. So make sure to submit your exercise before then. So the exercise, this has 3 parts. The first part is to create an account on github.com. We are going to use this a lot, like every week for everything during this course. So make sure if you already have an account, fine, you don't need to do this. If you don't, create an account on GitHub. The second thing you have to do is sharing your GitHub username with via Discord. So this is the second thing you need to do. join Discord, and on Discord write us your GitHub username. We need this for grading. So if you don't, very often someone doesn't do this at the beginning of course, and then at the end they come and they ask why they don't have any grades. Because if you don't give us your GitHub username, we don't know you exist. We cannot grade you. So make sure you do this week. And then you write a bit of Python, and I will show you briefly what it means. So there are instructions. It's simple to create an account on GitHub. Just go there, sign up pick a username, and use your email address. That's it. It's like signing up on any other website, as simple as that. And Discord, there are the instructions on how to use Discord. I'm sure most of you are already familiar, but if you're unsure how it works, there's a link here to the channel, and there are some instructions somewhere here in the course environment page. So what you need to write for us on Discord is your name, your GitHub username, the one that you pick, plus the version of code, the course code that you have enrolled to. So in case of David, like Dave Whip, this is his user ID on GitHub, and this is the version of the code course he has enrolled to. So this is what you need to write for us on Discord. And for those who are from other universities, for example, this is an example from Turku, this is how you write it. So your name, your user ID, and write that you're from Turku or from Aalto or whatever university you're coming from. Then in the third part of your exercise, you will be, what you need to do, we are using GitHub Classroom. This will make more sense next week when you learn how to use GitHub. But every week we have this link to accepting a GitHub Classroom assignment. And when you follow the link, you land on this kind of page. This is for exercise 1. And when you accept it, it creates you a repository. In my case, it will be named this. So this is my GitHub username, and this is exercise 1. So this is what it does. So it creates you a private repository. No other student can see your work. We can see, only the course instructors can see your work. Other students cannot see it. So everything you do is stored there, but we are not using it this week yet. Just remember to accept the assignment, and then you do a bit of so this lesson, the exercise repository is empty. In other words, there are notebooks ready and with empty cells that you will fill. This week, it's a bit easier. So what you have to do in this week, you do those first 2 things, create a GitHub account, write it on Discord. The third thing you need to do is to create a notebook file. And I showed you how you do it. So here, you just create a new notebook, like this. So you just create a new notebook and save it wherever you want. It will be saved in whatever folder you are in. And then in that notebook, like we did, you can write code, you can write text, and you do a number of things. So you have a few problems you need to solve related to what we did today. So defining some character string, do a bit of like simple calculations, and a bit of mathematics, like you calculate some very simple things. And then what you do, you upload the exercise to the repository that was created for you. So remember, you first create a GitHub account, then you accept the assignment. Once you accept the assignment, it creates a repository for you, like this. And then once you created your notebook file here, so in CSC you do your assignment, you do your homework, then you just download this. From next week we will learn how to just push this to GitHub. But for now we do it simple way. Download your notebook. In GitHub repository just upload it. So add file, upload file. So once you did your assignment, upload your notebook directly to GitHub, your own repository for exercise 1.
We have a different repository
Yes. Yeah. Every time you accept the assignment, a new repository for that week is created for you. So the repository is created automatically when you accept the assignment. You don't need to make yourself a repository. Just upload the file, and that's it. It's super simple for this week. From next week, we will learn how to use with how to work with GitHub, and things become a bit smoother. Yeah, so that was it for today. Do you have any questions?